Thanks, George. My name is Ben Bolles with the NexGen Storage product team. In this demo, I will show you how the NexGen Storage Quality of Service engine operates, and specifically how the Prioritize Active Cache works to keep the most important data in PCIe flash based on the customer's business priorities. So let's take a closer look. You may be asking yourself, what is the Prioritize Active Cache? The NexGen N5 PCIe flash array includes a full-featured storage quality of service engine, complete with service levels and performance policies. The NexGen N5 is a multi-tier architecture that moves data in real time between RAM, PCIe flash, and disk in order to meet the QoS priorities and targets set by the customer for their data. The Prioritize Active Cache, or PAC, is the function in the product that ties the QoS policies and the prioritization directly to how RAM and PCIe flash is populated with data. The overarching goal of the system is to maintain the active data set in RAM or PCIe flash, with the higher priority data having more data in the PAC than the less important data. And the customer controls this by placing volumes in the different priority performance levels. So how does it all work? The Prioritize Active Cache feature has been in the product for several releases now. We recently enhanced the functionality to be able to cache data based on VMware virtual volumes, and also to incorporate the RAM on the storage processors. The NexGen N5 has 5 performance policies and 3 service levels. Based on the volume QoS level, data is prioritized in RAM or PCIe flash. Volumes in the mission-critical service level are cached at the highest priority and have the most aggressive read-warming and read-ahead caching. Business-critical volumes have a normal level of caching, and volumes in non-critical policies are not cached at all. This way, the customer controls what data is prioritized into the cache by placing volumes in the appropriate QoS performance policy. Finally, and perhaps most important, the QoS policy of the volume can be changed on the fly, and it will affect in real time the Prioritize Active Caching for that volume. This is what I'll demo for you a bit later. The Prioritize Active Cache demo consists of a NexGen N5 1000 PCIe flash array running the version 3.5 operating environment on each storage processor. I have ESX hosts and vCenter running at the 5.5 revision level, and 2 Windows 2008 server VMs running IO meter to generate a workload. For the initial state of the system, I have the data stores set at a non-critical policy 5 quality of service. This means that the data for these data stores is not prioritized for flash, and the Prioritize Active Cache is not operating on these data stores. We will observe the N5 and VM performance and should see disk-based performance for IOPS and latency. We will then transition the system to a new state where the data store volumes are put into the mission-critical policy 1 quality of service. This means that the data store volumes have the highest priority for flash performance, and we will observe the N5 and VM performance for IOPS and latency as data is populated back into flash in real time. So let's get started with the demo. What you see here is the dashboard of the web interface to manage the NexGen N5. Right now we are running an initial workload that is primarily hitting disk and generating about 20 megabytes per second and 3000 IOPS at a 12 millisecond average latency. Looking at the provision screen, we see that the volumes we are going to be working with are currently set to the non-critical policy 5 QoS setting. The volume names are IO volume 4 located on storage processor B and IO volume 5 located on storage processor A. In the vCenter client, you see that I have 2 VMs that are attached to the data store volumes. TM Demo Win 02 is attached to the data store on IO volume 4, and TM Demo Win 03 is attached to the data store on IO volume 5. Let's look at the Windows VMs. You see here that I am running an IO meter workload on this VM. The disk target under load is the volume called IO volume 4. The workload is an 8K random read. And we are currently getting about 1300 IOPS at about 12 milliseconds of latency. In the Windows Performance Monitor, we see this translated to average disk seconds per transfer, or latency, of 0.012 seconds, or 12 milliseconds, and the disk transfers per second, or IOPS, is around 1300. The other Windows VM is running the same workload against the other volume, and we are seeing similar results of 1300 IOPS and 12 milliseconds of latency. Now let's look at the metrics for these volumes. You see here that the volume called IO volume 4 is seeing a response time on the N5 of about 12 milliseconds. And the IOPS for the volume is around 1300. We also see the same thing for the volume called IO volume 5. Latency is around 12 milliseconds, and the IOPS for that volume is around 1300. Now let's inspect how the IOPS are being satisfied by the N5. Right now, the PCIe flash tier within the N5 is not seeing any IOPS at all. Because both volumes under load are in the non-critical policy 5, nearly 100% of their IOs are coming from disk. The disk tier, on the other hand, is shown here with IOPS of around 2700, which is the sum of the IOPS of the two volumes under load. Now let's go back to the provision screen. Recall that both volumes are in the non-critical policy 5 QoS policy. We are going to move these volumes to mission critical policy 1. When I view the attributes of this policy, you will notice that policy 1 has a target latency maximum of 5 milliseconds. It is the latency target that we will see drive the QoS engine to move data from disk back into PCIe flash in order to meet those targets. Here I'm going to modify the two volumes under load and change the QoS policy to mission critical policy 1. I can do this on the fly, and the system takes immediate action in order to meet the QoS performance targets. I simply change the policy in the drop-down and then click on the Update Volume button, and the changes take effect. Now if we look at the metric screen, you'll notice that on the response time chart there appears a red line indicating the latency target for this volume based on the mission critical policy 1 QoS setting. And at the moment we are still getting about 12 milliseconds of latency and 1300 IOPS for each volume. So we let the system run for a few minutes and come back to observe that the prioritized active cache is being populated with data based on our change for QoS from non-critical policy 5 to mission critical policy 1. You will notice now on the dashboard that we are running at 16,000 IOPS and 2 milliseconds latency. This is about 5 times faster than before. On the metrics screen, look at the dramatic reduction in latency based on the migration of QoS policies for these volumes. We are now well below the 5 millisecond latency target for the mission critical QoS policy. We are just midway through the data rewarming of the prioritized active cache. Both volumes are now at sub 2 milliseconds of latency, and IOPS for both volumes continue to climb above 10,000. We let the prioritized active cache rewarming process complete and return to find that performance is now 12 times faster than before. IOPS are now close to 40,000 and latency now at 1 millisecond or less. When we look at the host performance, we see that IOPS are now at the 20,000 level and latency is at 0.7 milliseconds. You see here on the Windows Performance Monitor that disk transfers per second, or IOPS, are at close to 20,000 and latency is at 1 millisecond or less. Also notice how the green line for IOPS is climbing over time. This is indication that more data is being serviced from flash on the N5. Going back to the metrics screen, we now see that the prioritized active cache population is nearly complete. Both volumes have undergone a dramatic change in performance over the past several minutes. IO volume 4 is now at 0.46 milliseconds of latency and 20,000 IOPS. IO volume 5 is at 0.35 milliseconds of latency and over 21,000 IOPS. If we take a look at the disk and PCIe flash tier performance metrics, what we notice is an impressive change in how the IOs for these volumes are being satisfied. The disk tier IOPS have decreased dramatically. And because the data for these volumes has now moved back into flash, we see that the PCIe flash tier is servicing over 41,000 IOPS for these volumes. One last check on the Windows VMs, and we see that both are now operating at over 20,000 IOPS each. This represents a 15x performance increase over where the volumes were before. And the only thing we had to do was change the QoS policy on the volume to mission critical, and the N5 did the rest. Finally, let's look at the performance data collected on the Windows virtual machines. This first chart is for host or virtual machine IOPS. We see on the chart that up until the QoS policy change, each volume was running at around 1300 IOPS, basically all IOs being serviced from disk. Since the volumes were in the non-critical policy 5 QoS level, the prioritized active cache was not being used. Once we moved the volumes into the mission critical policy 1 on the fly, the prioritized active cache began being repopulated in real time. You see the dramatic increase in IOPS for both volumes until they reach a point where the prioritized active cache is populated and nearly all IOs for the volumes are being serviced from PCIe flash. Similarly, on this chart for total host IOPS, we see the sum of the IOPS for both VMs. Once the QoS policy change was made, the process for rewarming data into the prioritized active cache was initiated until nearly all IOs are coming from PCIe flash for the mission critical volumes. IOPS top out for the two volumes at around 42,000. Most impressive of all the charts for this demo is the huge drop in latency. Once the QoS policy change was made, we see the steady decline of measured latency at the host. Ultimately, once the prioritized active cache is populated, the IOs for the volumes are satisfied in sub-millisecond latencies to the host. This shows the power of the prioritized active cache, and it is very simple to manage by just placing your volume in the appropriate QoS policy, and then let the NexGen N5 PCIe flash array do the rest on your behalf. This concludes the NexGen Storage Quality of Service Prioritized Active Cache demo. I hope that you were able to learn more about how the Prioritized Active Cache capabilities of the NexGen N5 PCIe flash array will help you prioritize your workloads and solve your performance management challenges. And now back to George, where we'll do some Q&A and wrap up.